What are some of the specific challenges when it comes to making causal inferences on data describing human behavior?
The problem I see with Jonathan Haidt's work, I think, that he is tackling many things in a very sloppy manner. And it's sloppy on so many levels that it's really hard to criticize it. Because there's so many aspects that are just ignored, such as changes in diagnostic criteria, right? Like if you start telling all doctors they should screen teenage girls for symptoms of anxiety, you will find more diagnoses among these groups and so on. The girls report more strain on their relationship with their parents and so on. So this is actually just a part of the population that completely changed in its composition. And it does make it look like the gender gap opens, but it could literally just be like a different population that's moving in. But I think we have good reason to believe that this could actually be like a survey mode effect, that like answering on the tablet affects how the girls just answer to that question. I don't think it actually affects their underlying life satisfaction, but maybe just the expression of their life satisfaction, which points to the issue that you raised, that like the whole measurement thing is already a causal thing, and there are causal assumptions in there that people report the same way over time.
What would be 2 or 3 points advice from you to someone who is not a psychologist, but for whatever reason they need to work with questionnaires?
Determining which outliers to remove, or if to remove any, is not a matter, it's not a statistical question. I think from that perspective, it's like, oh, what do the DAGs add, right? You don't need the DAGs. You can do it without the DAGs. You just need to think harder.
Hey, Causal Bandits. Welcome to the second season of the Causal Bandits podcast, the best podcast on causality and AI on the internet.
She fights the replication crisis in psychology, but thinks that every scientific field has its problems. She loves causal graphs and clear assumptions. Personality psychologist on a mission to promote causal inference, advocate for transparency in science, and senior editor at one of the top journals in her field. Ladies and gentlemen, please welcome Dr. Julia Rohrer. Let me pass it to your host, Alex Molak.
Julia, welcome to the podcast, and I'm super excited to have you here. There are some things that our audience might be not aware of, and this is about our common background. So you're a psychologist by training, and I'm also partially a psychologist by training, and I'm very curious where this discussion today will lead us.
Yeah, thank you so much for having me on your podcast.
Great to have you here. You published a paper you co-authored in Nature Human Behavior called Causal Inference on Human Behavior. What are some of the specific challenges when it comes to making causal inferences on data describing human behavior?
So there was one of those many author papers, so there are a lot of names on there, and I only contributed a small part. But thinking about it, I think one major challenge that psychology faces is that we are interested in psychological causes, and these are kind of fuzzy, like, okay, how do your emotions affect your behavior and so on? Okay, how do we measure emotions? But also, what's our identification strategy here, right? So how can we maybe intervene on emotions to arrive at valid conclusions, or what else can we do to get at valid conclusions? And for example, I'm a personality psychologist, so I'm interested in causal effects of personality, and that quickly gets very complicated because kind of by definition, personality is like a stable disposition. And I mean, people aren't very fond of causal inference for stable dispositions. Like some people say they can't have effects and so on. So we have all these like major causal inference issues. And then there are different ways that the field is trying to tackle them. The default is kind of doing experiments, although that doesn't work quite as well for many of the variables we're interested in. And this is combined, I think, with a research culture that kind of denies the possibility of causal inference with observational data. So we are like in a very peculiar spot where the causal inferences are very, very hard. But at the same time, we don't train people to think about causal inference rigorously.
When people think about so-called reproducibility crisis in sciences, psychology is often one of the first disciplines that comes to mind. And that's probably because around 2010s, there was this huge discovery that many seminal studies and many very popular studies in psychology were not replicable. So when other teams were trying to replicate the experiment as closely as possible to the original description, the results were surprising in a sense that they were different from the original results. You worked on reproducibility, and I was very curious about your thoughts. What role can causality play, or causality education play, in improving the state of affairs when it comes to reproducibility?
So I'm not sure how much causal inference can really contribute to reproducibility directly. However, I think those topics are very closely connected. And so my original, let's improve science background is from the open science side. And I think if we look at these failed replications, they will often be experimental studies. So it will often be, the causal inference is kind of plausible, but then the statistical evidence is so weak and it's likely been slightly p-hacked to get the right results. And so what I've been seeing, actually what people do now is, so let's switch to something more robust. For example, let's do correlational studies of questionnaires. And it turns out that these tend to be highly replicable. And that is because it's cheap to collect, so you can get thousands of data points, but also it's very likely that you have some bias or confounding in your data. And that confounding happens to be super replicable. So my background is personality psychology, and personality psychologists like to get smug about how our findings are super replicable and are not that affected by the replication crisis. So it must be something that we are doing right. But the thing that we are doing right is just taking correlations between self-report measures that are highly confounded and thus super replicable. So I think in a sense, the push for better causal inferences and the push for higher reproducibility, they need to work together. Otherwise, people go for the findings that are easily replicable, but most likely confounded.
That's very interesting. I'm recently reading this book called Apes in Lab Coats. I don't know if you know this book. It's by Dennis Landrum. I bought it because Stephen San recommended this on LinkedIn. And we had an interview with Stephen in the first season of our podcast. And so Landrum is writing about he's sharing a couple of interesting insights here in this book. So one of the insights is that psychology is one of those sciences that infamously were very often mentioned in the context of reproducibility crisis. And so many people think that social scientists maybe are not very, very well equipped to run experiments. But what he says here is that in social sciences, often people are more aware about the role of things like randomization, variability, and impact of those things on the results and on experimental design and on interpretation and so on. He says that's not necessarily the problem, and the penetration of these ideas related to experimentation and causal identification is in fact, according to him, much lower in so-called hard sciences.
So that is an interesting claim. I would say, so psychologists are very aware of the need for randomization, but to the point that it's just like a given, right? You need randomization for causal inferences, but then people also kind of forget why. So it's just like a rule that you learn by heart, and that does lead to all of subsequent inferences that are just wrong. So for example, people will assume, I did a randomized experiment, I manipulated that one factor. Right, but now I'm conducting a mediation analysis and I have that mediator that I just observed and that I did not manipulate. Or I'm interested in how the effect of my treatment varies by this third variable, which also wasn't actually randomized. And so there is very little awareness that the randomization of one thing does not justify all causal conclusions. So one can say this is a good thing. Psychologists do know, I should randomize something. In practice, I think it would be good to teach them a bit more so that they are aware why they are randomizing that thing and which inferences are supported by that. And then, of course, there are huge parts of psychology that are not experimental and that cannot possibly be experimental. And those are just left ill-equipped. So I do kind of agree that psychologists do have the underlying right idea that experiments are great. They don't quite fully understand why, and thus certain things go wrong. But another part of this is, I think, psychology is always invoked for the replication crisis. But it has been my impression when I talk to other people at conferences and in private, it's very much that other fields of research, like epidemiology or economists and so on, are it's so great that you already had these debates. So there is already awareness that findings can be false positive, right? And if you try to make that point in economics or in epidemiology and so on, you're at the discussion just isn't quite that far yet with respects to just high variability in findings and a lack of replicability of findings and a lack of computational reproducibility. I think psychology kind of gets to be the scapegoat, but it really is that we have been really just kind of laser focused on highlighting these issues, which is good, I think. And my hope is that this inspires other fields to move along and to also have these discussions. And for people trying to start these discussions in the other fields, it's always good to be able to point, oh, look, in psychology, this and that was discussed. What does it look like in our field and so on? So I do hope that the discussion kind of spreads. And I mean, it's unfortunate if people get away with the impression that psychology is not to be trusted. I think to some extent that is justified. It takes a lot of expertise to figure out like what's the noise and what's the signal when it comes to psychological research findings. But I think in a broader perspective, it's probably good for science. There is one field that really went into that. And of course, in medical research and so on, there have been these discussions as well. But I think psychology is special in that it has been super serious about that and the public has been hearing it. Maybe because the public was suspect of psychology in the first place, or maybe also because the hard sciences like to make fun of the social sciences and so on. But I think it's a good development overall.
That's very interesting. There's a relatively recent article in, I think, New Scientist that focuses on reproducibility crisis in physics. So this is something we hear about much less often, but it's also happening. And perhaps this is also related to the ideas that Landrum is discussing in his book regarding maybe a lower awareness in the community regarding the sources of variability and their potential to impact our results. You have a very interesting paper, and a paper with a very interesting title, and this time this is your solo paper. It's called Causal Inference for Psychologists Who Think That Causal Inference is Not for Them. Why do some psychologists might think this way?
I think, and so this is just the baseline. Nobody in psychology thinks they are doing causal inference based on observational data. Everybody is doing something else. So either you're running experiments and you're not aware that the mediation analysis is in many ways an observational analysis, or you are looking actually at observational data, but then you just change the apparent goal of your research. So I get to see a lot of manuscripts as a senior editor at Psych Science, and there are so many predictive models. A research study will be framed as, we are trying to predict this relationship outcome or something like that. And then it will be framed as a predictive research question, but both the introduction and the discussion make it 100% clear that this is about causal inference. I want to know how your partner's characteristics or behavior affect your relationship satisfaction. And it really only makes sense from that perspective, because if you took that literally as, we are building a predictive model, well, you're building a predictive model that uses as an input 10 really long psychological questionnaires and then predicts a single variable. Sometimes it's not even in the future, but at the same point in time. And that single variable is a 10-point rating of your relationship satisfaction. What would you do with that model, right? In which situation do you need to predict people's numerical assessment of their relationship satisfaction and have all these variables to feed into your predictive model? That is quite unlikely to happen in practice. It's also not how, as a relationship therapist, you would work, right? You wouldn't have a numerical prediction model. Instead, you would want to know, what affects relationship satisfaction, right? How can I tell whether this is going to make you unhappy or happy and so on? And that's actually causal inference. It's just not treated as such. So there's that thing that people know that there's a lot of uncertainty in causal inference based on observational data. And now instead of trying to draw these causal inferences, but adding all the care and pointing out the assumptions, instead they pretend they were trying to answer a different question, to which they can give a certain answer. There's an association here. And then the uncertainty is, we observed this association. What could it mean? Well, maybe it is causality, who knows? So it's moving the uncertainty into the research goal rather than into the answer that you provide. And I think this is very unfortunate. It is sort of an adaptive strategy to cope with the knowledge that the correlation does not equal causation. But then, you can only get correlations. You don't know how else to get at causation. But then you need to tell a causal story. And so it's kind of like a hodgepodge of things that you mash together into a single paper. And this is really this is such a common phenomenon. like when you start pointing it out to people, they're like, oh, but this is how we write papers. Like, this is all of our research. How could this all be confused or conceptually wrong in a manner? And so it's really like deep in the field. People will highlight these papers as like examples of really good work, but it's like, okay, but the study doesn't even get the research question right. And so this is the one thing I'm up against right now. And I think it's like the mission I'm on now is like make people realize that they are actually trying to draw causal inferences, and it's fine. It's okay. So it's not meant as, oh, you're drawing a causal conclusion here, I'm going to reject your paper because of that. It is, you are trying to draw a causal conclusion here. That's the right thing to do. That is what we're interested in. Now, let's make this in a more systematic manner.
What do you think is behind this, this cultural, let's say, this cultural coloration, of the field of psychology? That this is the way we write papers, this is the way we think about it, and so on.
So I think if you go back a bit more, I think part of it that psychologists have that strong self-concept that we are very sciencey science. We are like a natural science. We have an experimental tradition, right? And so if you ask psychologists where like modern psychology starts, it will be here at Leipzig, it will be Wilhelm Wundt and the first like psychophysics lab. So this is very close to our physiological research. It's all experimental and so on. And I think many psychologists like to think of themselves in that tradition and not in a philosophical tradition. I mean, that would be just as valid because we do have these roots, right? But we like to think of ourselves in that like purely natural science experimental tradition. And then there's just a mismatch with the research question that we're actually trying to answer and with the broad domains that are covered by psychology, right? So we are not all cognitive scientists running like experiments where you have to push buttons. We do lots of different things, but somehow we like to think of ourselves as these sciencey scientists. I think that leads to some mismatch, and then people just try to cope with it. And they come up with strategies that seem like good solutions and so on. I think there's also like a dynamic in here. And so this is something I got from Konrad Körding, who talked about a different corner of psychology, which is like neuroscience, where people talk about functional connectivity. And so you put people into an fMRI scanner, and then you have all these voxels in their brain light up, and then you do fancy correlations between those voxels, and that is functional connectivity, right? And it's a correlation, it's a fancy correlation, but it is a correlation. In the best possible case, it might be something like Granger causality, which is just not causality, it's something else, right? And some people are aware of that, but at the same time, the whole field profits from just kind of ignoring it. And so his point was a bit is like, you submit a paper that does this functional connectivity analysis. It's clear that it shouldn't be causally interpreted, but then the reviewers are in on the whole thing, right? The reviewers are publishing their own papers that are telling those causal stories based on these correlations and so on. And so nobody is really incentivized to say, okay, let's stop this. Right. And the same, for example, is true, I think, for personality research. So personality research is a lot of like, oh, we are correlating some self-report measure of personality with something important in your life. And it's very easy to find correlations now. Things just correlate, right? And then it's like, oh, this is like the unique predictive role of extraversion for whatever outcome it is you're looking at. And then there's lots of ambiguous language to make it sound, oh, this is the importance of extraversion for career success or something like that. And so you could say, yeah, but what do you mean like that? What's the role of? What is the importance? Do you mean to say that this has an effect, or do you mean to say something else? But nobody profits from asking these questions because personality research as a field like thrives on the notion that personality is really important. Everybody wants to think that personality is really important. Being really important means it has all these causal effects. So nobody quite profits from pointing out that the emperor has no clothes on, maybe that we don't have good reasons to make these causal claims or these implicitly causal claims. And so I do think it's an incentive problem in that we are not really incentivized to criticize like the premises of our own field. And this is why I'm always super excited when I can get reviewers from outside of psychology. We're just not willing to go by this. Oh, we implicitly agreed that it's okay to put it this way. And then we're like, wait, what do you mean here? Like, what's that supposed to mean? Like, what are your assumptions here and so on? And I think we really need that input from other fields to highlight these issues.
Before closing the topic, leaving the land of reproducibility, I wanted to ask you one more question, because I remember in 2010s when the reproducibility crisis started to be too loud to be ignored, so to say. We had people like Brian Nosek, for instance, and we had this multi-lab replication project, if I remember the name correctly. How successful these initiatives has been from the perspective of 2025?
So from my perspective, and I'm a bit biased because I'm sort of part of that movement, but I do think it's astonishing how much has happened within only 15 years. So people will be like, what the hell? We've been debating about this for only 15 years. But I think we have seen some super important changes. For example, the notion that you should make your data available to others to verify your findings. I think that was perceived as like threatening and maybe even like, how dare you like ask me for the data, to at the very least, people agree that this is desirable and should be the norm. So people might still try to find excuses, and they're still like, oh, but what in this edge case where I absolutely cannot share the data? In which case, of course, all the open science advocates are like, no, then you shouldn't share it, right? It's okay. It's like just like in the different situation. But I think we have really shifted the discourse from you need to justify why you would want to check anybody's findings. You need to justify why you would want to look at their code, right? Their code is none of your business. To, in principle, this should be delivered, and in principle, it should be checked. Now, how often it's actually checked and how often people come up with excuses and so on, that is like a different manner. But just shifting the default norm from you can't ask for that, it's a weird thing to ask for, to no, obviously, if you want access to these things, it's your good right to ask for them. And then the authors are in the position that they need to deliver. So I think a lot of happened there, and I do know it's like hard to keep track of change over time. I mean, this is a causal inference problem, but it's also like the age period cohort problem, right? So when I think back, I was also a lot younger. I was a lot more passionate about things, right? And now I might feel just like, oh, nothing actually changed. It's all still like horrible and so on. But I think some of these changes are just like, I have a different perspective now. I'm less passionate about these things maybe as I've aged. But I think objectively, there are many indicators just that the norms have really shifted. There's a lot of good change. So, for example, I'm at Psychological Science, and the editor-in-chief now, Sabine Vazir, has been super involved in all the replication crisis, open science discourse. And we are now like really on a policy level, on the level of the journal, implementing many new things such as reproducibility checks. So it turns out that is a lot of work. But in principle, if your manuscript is accepted at Psych Science, it's accepted pending a reproducibility check. And then we have a team of so-called star editors who try to reproduce the findings. And I know other journals have done that before, in political science in particular, but having this at flagship journal in psychology is sending a signal to everybody. Okay, so this is where we're heading now. This is how we're doing things here. And it's such a difference if you compare it to 2010, when people barely had data in any shareable form, or maybe some Excel spreadsheet with multiple pages and so on. And we're like, oh, why should I take care of that? To a point where it's like, oh, okay, if I want to submit to this prestigious outlet, I better make sure that everything is reproducible. And I think these are like huge wins. And then there are many things that are still not perfect. There are some situations in which like the interventions have resulted in like negative side effects. I think one of them being researchers thinking that just correlating stuff is an easy way out. And it is. You will get replicable findings, but they are just not very meaningful either. So there's these other topics that we have to tackle now. We need to discuss theory, we need to discuss measurement and so on. But overall, I'm quite positive about the developments.
What do you think would be the main lessons for people from other fields from this progression that we observed in psychology in the recent decade or decade and a half?
I don't know how much generalizable insight there is. It isn't trivial. I think one important thing I think that psychology has highlighted is that maybe before venturing out to do like super expensive replication studies, maybe first check using the original data whether it actually holds up, because in many cases it turns out it doesn't hold up. And then you can still ask, oh, do I still want to replicate this, right? But you need to update, right? Oh, wait, the original finding wasn't what it looked like. So maybe now the replication isn't quite as urgent anymore, and so on. So I think there have been a lot of developments in psychology towards, oh, let's not indiscriminately like replicate everything, although I think nobody tried to do that. But I would be careful to say, oh, a replication is only meaningful if the study is super important and if there's genuine uncertainty. Because at the same time, I absolutely see how the large reproducibility project we had, in which 100 studies were replicated, it was important, not necessarily to find out the precise rate of replicability in psychology, but rather just to raise awareness. So we just picked some studies from some high-profile journals, and they don't replicate. Now what? And this isn't maybe the most effective way to conduct 100 studies, and maybe not the most informative, but I always think about, like, what role does this now play for the field? And it might be necessary to do something that, from a scientific perspective, many of these studies might have been preposterous in the first place, but it's still good, right? Like, people take the literature seriously, so let's take it seriously and see how replicable it is. From that perspective, I wouldn't say, oh, you need to handle this differently. I think you do need to, like, raise awareness. You do need to flag that this is an issue on a broad scale, and then you can go into all the details and so on. But you do need to have the willingness to discuss this as a big problem.
When we started our conversation today, you said about psychologists having this challenge that we often need to work on using latent variables. So if we say, like, oh, this is, I don't know, whatever, emotional state or emotion, or this is a personality trait. These things are very often, probably more often than not, directly observable. They are our inferences about certain observations, right? And they are in themselves, in a sense, causal models of what is happening inside a human, right? Or another animal, if you're a comparative psychologist, for instance. One of popular topics recently has been the topic of anxiety and depression in younger generations. And some of big names in psychology, and here I mean primarily Jonathan Haidt, proposed that social media is behind this change that we observe. This hypothesis that he proposes involves many latent variables. Mm-hmm. It also involves inferences over time. And when we combine all of this and a couple of other challenging topics that I'm sure you will probably discuss in the answer to my question that is coming, when we combine all of this, it gives us a very challenging cocktail of things, especially when we look at this cocktail or want to look at this cocktail from the causal point of view. What are your thoughts about Haidt's hypothesis and his defense that the claims he's making are actually causal?
So that is a very good question. And so I am kind of following this discourse. I think my co-blogger Ruben Arslan is a lot more involved and actually going into it quite deeply. But I'm actually just right now working on a manuscript whether the gender gap in life satisfaction among students in Leipzig has widened, which I think would be aligned with, like, the popular narrative that like it's girls who are getting unhappier now because of social media. Now, in principle, I think the idea that social media impacts people's well-being, like, it just rings true, right? It has the right vibes. It has the right vibes for me as well. And in particular, I think I found a good way to deal with social media. So I mostly get positive emotions out of it, right? And when I see that, oh, I'm now scrolling Reddit and it's all horrible, actually, I just stopped doing that, right? I don't need to make myself feel miserable. And instead, I'm having a good time on Blue Sky with other people working on similar topics. Or I have a Slack with close coworkers. And I actually think a lot of young people are more moving into close spaces where you have, like, your friends and actually you're just chatting on WhatsApp or something like that. But in principle, I could see that if you like for individuals who haven't figured out a good way to integrate this into their lives and so on, it could be an obvious issue. And then there is, I think, always there is edge cases where people find a community that's not healthy for them, right? That resonates with them, but that leads them actually to develop mental health issues as they are overly focusing on one aspect of their lives, right? And so in psychology, in principle, right, the idea that how you think about things affects how you feel and might lead to mental health issues, it's super valid. And it makes a lot of sense that things like that could happen on social media. Now, the problem I see with Jonathan Haidt's work, I think that he is tackling many things in a very sloppy manner. And it's sloppy on so many levels that it's really hard to criticize it because there's so many aspects that are just ignored, such as changes in diagnostic criteria, right? Like if you start telling all doctors they should screen teenage girls for symptoms of anxiety, you will find more diagnoses among these groups and so on. And so some patterns in the data that he picks up, I think, are such diagnostic changes and so on. And this is leaving out the whole issue, right? That, of course, apart from that, diagnostic behavior might change in its own right, which we know from, for example, autism diagnoses, right? So there are studies that suggest that the symptoms have been fairly constant, but then diagnoses have ticked up. And I mean, this is very much like one of those measurement issues, right? Like, what's the causal connection between the thing you're interested in and that which you can observe? So there are these issues. Then there is just like, the thing where you take like a timeline, and then you see something goes up and you're like, yes, this is where social media started. It doesn't quite work like that, right? Like, I mean, this is more like economists' domain, but being like, oh, I have a time series and here something happens, so this is causally attributed to what happened there, is kind of, it doesn't quite work that well, right? And so I think there are layers upon layers of issues there. Including, I think Haidt says like, oh, I'm super open to criticism and so on. And so here's like a page of errata and so on. But then he repeatedly gets called out for known issues in his data and so on. And they don't show up on that page. At least they haven't showed up in the last time I checked. So there's like a commitment to, let's do this super scientifically and so on. But then it's kind of like playing it very loosely. And I know a lot of psychologists play it loosely in that manner, right? You just throw more data at people. And then you hope that they agree with you that you can't deny that something is happening there. And I don't appreciate that. I don't appreciate it in particular because I think this is an important research question in which I'm interested myself, right? And I have young kids and it will be relevant for them as well and so on. So I wish there was better research there. I'm 100% certain that social media will have negative effects for some people. And I'm also quite certain that it will have positive effects for other people, right? So this is kind of like a given because the effects will, of course, vary depending on what people do online and so on. There are these like broader, like cultural counterfactual questions, like what would the world look like now if we didn't have social media? Would we have Trump or not? And so on. But these are like a different level of analysis again, right? And this is not something at which you can get easily with randomized experiments where you tell people to stop using their phones and so on. So I think it's just a lot of uncertainty there. And I mean, for example, I can tell you a bit of my own study that I'm working on if you're interested in that. The city of Leipzig conducts surveys of school children. And so we have data from 2020, 2015, and then 2023. You can already tell that the gap there got wider because during COVID, they couldn't go into the schools to collect data. So you already know, oh, something changed there, right? And so in our data, there does seem to be a pattern. So first of all, everybody is slightly less satisfied with their lives in 2023. So this would be life satisfaction as one possible measure of subjective well-being. It's not the same as mental health, but of course it is correlated with that, and it's a good indicator of how people feel about their lives. And so first of all, we see that everybody is slightly less happy, which I think makes a lot of sense because these are students who had the COVID-19 pandemic during a critical phase of their life. So this was definitely an advantage, and it will impact their well-being, at least for the time being, right? But then we also see that the gender gap seems to widen more among girls. And that's kind of curious, right? Like what's going on here that is making girls less happy? And so we kind of try to figure it out because it turns out it's not quite that easy. For example, we do find that the widening of the gender gap is super pronounced among students with a migration background. Then when you look at the migration backgrounds in Leipzig, they changed a lot. So in 2010, we mostly had students with a Vietnamese migration background. So these were like contract workers who came to East Germany during the socialist days and so on. And then they had children. And these are like the students with a migration background in our 2010 data. And this is just a very peculiar group. So for example, they were like super successful academically speaking and so on. And if you now take the 2023 data, the students with a migration background, they are often from Syria, Afghanistan and so on. And it's entirely plausible that there we just have different gender gaps in life satisfaction. And it is quite plausible that they are larger in the populations from the Muslim countries. And it seems to be the case that the students also report, like the girls report more strain on their relationship with their parents and so on. So this is actually just a part of the population that completely changed in its composition. And it does make it look like the gender gap opens, but it could literally just be like a different population that's moving in. And then we're having all sorts of other issues. So, for example, in 2023, they started collecting paper on tablets rather than on paper. So we find that super peculiar thing in our data. So they couldn't always use tablets. Sometimes they had to switch to paper because some schools opted out, which obviously is like endogenous to the school. But sometimes it would also like they had not enough tablets available because there were multiple classrooms being served at the same time, or they had technical issues and so on, or they had no Wi-Fi. And so some classrooms used paper. And now we have that very peculiar observation that the gender gap is larger on tablet than on paper. So the girls who responded on tablet report that they are less satisfied with their lives than the girls who responded on paper. And that's not the case for the boys. For the boys, it's exactly the same average satisfaction. And of course, this could be confounded because we don't quite know how the classrooms ended up using paper. But I think we have good reason to believe that this could actually be like a survey mode effect, that like answering on the tablet affects how the girls just answer to that question. I don't think it actually affects their underlying life satisfaction, but maybe just the expression of their life satisfaction, which points to the issue that you raised, that like the whole measurement thing is already a causal thing, and there are causal assumptions in there that people report the same way over time. So with all of these nuances, we still find slight widening of gender gaps, but it's in particular for social life and for leisure time activities. So there might be something that makes girls unhappier relative to boys, but it's kind of limited to a certain space. And there are all these other things happening. So we do have that change in the underlying population. We do have the change in survey mode. And so maybe girls just have negative associations with tablets, or they are not confident using them. Or maybe the boys are just like, oh yeah, I love this. This is where I play my games, right? And so they are not affected by it and so on. And we have all that nuance in there. And the conclusion is less catchy than like smartphones or social media are ruining a population. But I do think it's also more interesting to actually look at it more closely and to try to figure out what's going on. And so my one major concern, and I think this is not something that we could easily rule out just by collecting more data or running fancy analyses, and that is, of course, that the possibility that how girls assess their lives might, of course, have changed. And this could actually be due to social media, right? Like social media might, for example, give you a sense that, oh, actually you're entitled to the same as boys, right? So like certain feminist narratives and so on. And then if you check it, how's my life going? And now you translate that into a number, the translation might change because you're like, well, it's going fairly well, right? But I see that I'm being held back maybe by society. So your rating gets lower, right? And we just can't distinguish that from substantive changes in the life satisfaction, right? Because we just get the observed data. And now people do try to like, oh, let's use a multi-item scale and then let's do an analysis of measurement invariance. However, I don't think that there are statistical solutions to the philosophical issue here. And I think ultimately for that part, the solution is really that you need to talk to people and ask them like what goes into that decision. And there is exciting forthcoming on like in preparation work on that by Mark Fabian and colleagues, where they actually ask people how they use these scales, these life satisfaction scales. And it's already super interesting because, for example, if you give people a scale from 0 to 10, they will tell you, I'm a 7. I think an 8 is the highest I could be. If I had a higher value, I would need to be a different person, and I don't want to be that. So, and this is like, if you think about it that manner, it's like, oh, okay, so what variability are we actually capturing with that item? Because people explicitly tell you, like, in this world, there is no version of them in which they were a 10. So does it mean you should rescale the data and the 8 becomes the highest option for them? Or what does that have as implications if you aggregate across people, which you always have to do, right? And I think there is a lot of stuff going in there. And I think one conclusion from that line of literature for me is that these life satisfaction scales, the very top, they are kind of like losing their regular properties. It's no longer the case that you can just assume that just because somebody gave a higher number, they are actually more satisfied. So maybe if it's from 0 to 10, maybe the variability 8, 9, 10 is not whether people are more satisfied, but rather whether they are like how they think about their lives and the best possible world and so on. And I think that does actually affect this whole literature, because at least if you look at Western countries, you often do have a lot of bunching at very high responses. So usually like a 7 or an 8. And that does mean that it's unclear which variability we actually pick up. And then if it comes to looking at people maybe in the global south, I'm less concerned about that, because there is, I think, a clearer mapping between like 5, 6 and so on. It's like, okay, it's going better now, so I will give a higher number. But we are kind of reaching a point of saturation here where people can't really imagine what the 10 would be.
That's very interesting. I had a conversation recently in the context of doing causal inference in the tech industry, where you also have some kind of questionnaire, some kind of response on a scale. And I had a conversation with this person that, like in psychology, people sometimes say, well, we can treat it as a continuous variable, the response on the questionnaire, right? Others will argue that, well, the mapping is actually, it's an ordinal mapping. We cannot make it continuous because the differences between 2 and 3 might be very different than 4 and 5. But now what you're saying is that there might be another challenge, that people might actually think that their scale finishes at 8, even though the nominal scale finishes at 10. And I think that's a completely new dimension, a completely new challenge when it comes to thinking about those questionnaires as valid variables in any kind of inference scenario.
Yes. And so people always argue, oh, maybe it's just an ordinal measure at best, right? So you need to like fit a cumulative probit model, whatever. But that is like the easy part, I think. And I mean, we do that in our paper just to confirm that the results actually don't change at all. So that's the part that people like to argue about, because it is like, oh, there could be like an objectively right or wrong answer. And we kind of know how to get at it, right? Because we know that the ordinal model is the more general model. And so you should actually always just run the ordinal model, except you don't, because it's complicated and you don't understand it. But that is like the easy part. I think the much harder part is, okay, are people actually using that scale in the same manner? And people use scales in different manners. Like I'm teaching questionnaire design, and it's obvious that people interpret these scales in a different manner. And one example is when I was studying psychology, my then partner, now husband, would sometimes be like my guinea pig. And so he had to fill out some questionnaire. And there was like some item that was like, oh, I am like fairly happy with this or that. And then he would be like, oh, but wait, the response scale is now like agree, like don't agree a bit, very much agree, and so on. And he was like, oh, but now if I take this literally, then maybe my answer should be. And it's like, no. It's not supposed to be meant literally, right? Like usually if we ask like dichotomous question, we still hope that people use the whole scale to just give us their like variation of where I am on this, and not take it literally and be like, oh, this is a dichotomous item, so there are two possible answers here, the one end or the other end. But there are these people who take language quite literally, and they might be overrepresented in computer science, I don't know. But it is like, it is raising all these measurement issues, and we do know that it's a problem for happiness scales also in another context. So we have that nice scale that goes from 0 to 10 or 1 to 10. And it turns out that some people are just overwhelmed by that and turn it into a 3-point scale. So it's 0, 5, or 10, or 1, 5, or 10. And then you will have bunching of responses there. And it does seem to be people, for example, with lower levels of education, which makes sense because they might be just cognitively overloaded. Whereas me as a psychology student, I know how to use these scales. I've done it 1,000 times. And for them, they might simplify it into something simpler. And then it might actively bias our conclusions with respect to, for example, how educational attainment affects happiness, because our happiness measure just operates in a completely different manner depending on the level of educational attainment. And so these are issues that go under the label of measurement invariance, I guess, and I'm going to submit a paper on that today. But I think treating it just as like, oh, this is a statistical issue and we run these model checks to get at it, it's just not cutting it. It is going deeper than that, and I would be excited if people took that more seriously and also did more qualitative studies. I would like to see more of that, because I think a well-done qualitative study is a lot more informative than like a shoddily done quantitative empirical study that just follows like a standard template and correlates a bunch of variables.
Great. Congrats on the paper. What would be 2 or 3 points advice from you to someone who is not a psychologist, but for whatever reason they need to work with questionnaires? So maybe we can imagine someone working, I don't know, at booking.com or Google, and they want to measure the satisfaction of their users with an app or like another or some aspect of the web page, for instance. What would you say?
So, I mean, my top advice, but this is more top advice I would give to psychologists because they are more likely to forget it. And I think actually people in the industry might be more aware of that. But like, you should absolutely like closely look at the items and fill them out for yourself. And just like, you know, keep an eye on what am I thinking while I'm filling that out. And then maybe also hand it to a couple of other people's, because you are the one designing the survey. So you're kind of biased to say, oh, this is all fine, right? So give it to your partner, to your roommate, to whomever, right? And let them fill it out and let them tell you afterwards or why they are doing it, like why they are giving these answers and what comes to their mind. And so this is what I teach my students to do. So it's a lot more actually looking at the content of what you're asking and whether that makes sense. Then there's often like the mistake that people use response scales that don't fit the items. That is very unfortunate now. It is just like inelegant, and you can avoid that easily by giving it to somebody who has a skeptical eye on that. So this is, I think, what I would consider very important. And then there is, of course, all the standards like stat step, right? Oh, is it really a continuous variable? Should you analyze it as an ordinal? Well, just do it as an ordinal. It's fine as long as you can interpret the model. But then I think what's important is to keep in mind when you try to interpret finding, you just always need to keep in mind, okay, your outcome is people's agreement with that statement or people's response on that questionnaire. It is not necessarily the thing in itself. And I think that awareness is often sufficient for you to be able to generate alternative explanations here, right? It's like, oh, maybe they're just saying that, but they are saying that because of this or that, or because they want to make me happy, or because they feel that they might get, if it's people working for you, they might feel like they are being monitored and so on, so they might get different questions. And so keeping in mind that distinction between the thing you're interested in and the responses that people give you, I think is a good rule of the thumb, just to get in some like critical distance and be aware of potential alternative explanations that could be just as plausible.
In psychology, we sometimes inspired by psychologists, statisticians, right? Those people with these two backgrounds, we sometimes repeat items in questionnaires to check validity, or we add some items with negative framing, right? So if somebody says like, oh, I agree with this to 10, then I should disagree to 1, right? The response should be reversed. In practice, we know that these repeated questions and the negative formulations or like different formulations of the same question might be also discouraging for people and make them churn from the question or drop the questionnaire. What would be your advice for people working on questionnaires when it comes to this aspect? This trade-off between validity and providing a sensible user experience to the user?
First of all, I would advise from presenting the same question over and over again, mainly because I think hopefully the people filling out the questionnaire are thinking human beings, and it's a social situation. You are asking them questions, right? And they are answering. And so imagine if like you ask me the same question like twice in a row or with some time in between. That's weird. Like, why are you asking again? Do you want to hear a different answer this time, right? Like, should something have changed in between, or do you want to have the same answer, and so on? So there are all these like things that happen that you notice if you actually like participate in your own study, where you're like, oh no, this is really annoying, right? And so on. So I know that it is a problem, in particular if you collect data online, that there could be malicious responding and so on. I think bots change all of that anyway. So maybe this is going to be a different topic in the future altogether. But I would try always to do any like screening for attention or seriousness and so on as early on as possible, like before the actual part starts. There are other reasons why you would want to do that, because if you have the attention checks baked into, for example, your outcome variable, and then you exclude respondents because whatever they report is not plausible or is not consistent, then you are actually conditioning on a post-treatment variable. So this might be causally affected by whatever you're interested in, and this might actually just induce new bias. And so we actually have a blog post on that. A PhD student of ours, Time Azalti, and he's just talking about how excluding careless responses requires a causal justification. Because the careless responses might as well be valid responses. And if you discard them, you might be inducing bias and inducing new associations in your data. So I would always suggest, from a causal inference perspective, but also from a user perspective, to check that as early on as possible, and then do the questionnaire with an eye on the user experience, not asking the same thing over and over again. So I know people also do that to ramp up Cronbach's alpha, to get this is a highly reliable questionnaire. I think that's never a good justification to ask questions that are fully redundant. So if you reach the point where you are like, okay, I'm trying to come up with 10 different ways to ask the users whether they like this or not, I think you're just doing something wrong on a substantive level. You have a narrow construct, right? You can ramp up that statistic by asking it over and over again, but your measurement is not going to get any better. It's just like the impression of higher reliability. So maybe don't just ask one question, but just keep it usable. And so, for example, I think people working in the industry might have a much better eye on that than psychologists. We will just go all out and do 30 items for people's attitudes towards recycling and think that's reasonable because it gives good statistical properties. And it only works because we can force undergraduate students to fill out the surveys for course credit. So in many ways, I think psychology there has some problems that are less likely to occur in the industry and less likely to occur if you just stop and think about what you're actually asking people.
When we think about the data and removing observations from the data, many people who had some introductory statistics class or data analysis class probably heard this word outlier. And people say if it's 5 standard deviations, 6 standard deviations away from the mean, that might be an outlier, right? Especially when it's, I don't know, just 1 point or 2 points and so on and so on. But we know that sometimes these outliers, sometimes they might come from the measurement error, and that might be a reasonable assumption. But sometimes they just have some causal mechanisms behind them. What are your thoughts about working with outlying observations and removing observations? So you mentioned this very interesting idea that if we remove a response from our questionnaire data, we might actually introduce a collider bias, as I understand, right? Because this might be driven by the outcome.
Collider bias, yes.
With outliers, more generally speaking, what are your thoughts on working with these observations, and what would be your approach?
So again, my take would be that determining which outliers to remove, or if to remove any, is not a matter. It's not a statistical question, right? It's like the substantive question. Do you believe that this person has such a high value because actually the value does not reflect what you're interested in, right? Maybe they, slipped while they filled out the survey on their smartphones or something like that. Or are you just blindly applying a statistical criterion? And so, for example, my own research, I think I've never removed outliers. And to be honest, I'm in a privileged position here, and then I'm working with fairly large data sets. So I think it shouldn't make a difference either way, right? Unless those outliers are systematically biased. But then if they are systematically biased, it's raising the question, okay, what's going on here? And I think you can't get around that concern, what's going on here. So, for example, if you have a reaction time experiment, right, and somebody is just way too slow, maybe one point why one idea why the data point might be invalid could be, maybe they were inattentive and they didn't even notice that the trial started and so on. But if you then exclude these observations, you need to keep in mind, okay, I'm now conditioning on attentiveness. And attentiveness might be causally downstream of your experimental intervention. For example, if the conditions vary in how much attention they demand and so on and so on. So my personal intuition, but I'm not working with these types of data, so I'm not the substance expert, but I would always do the full analysis as well. And if there are discrepancies, you need to be very certain that the people you excluded because their data are invalid and not they are excluded because they are in a part of the distribution that's far out there, which might as well be the case. So some people just are far out there, right? Like there's a lot of inter-individual variability. And maybe I'm not removing outliers because I'm a personality psychologist and I'm like, oh, people are so wonderfully different in so many ways that we can't anticipate. So if people just tell me they are way out there, I'm just going to believe that. But of course, it does raise concerns now in combination with you don't have full control over the data collection and so on. You don't exactly know what's happening there and so on. And so there are trade-offs here. I would personally, I'm not a big fan of outlier removal, but I'm also working in a field and with types of data where it's less relevant. I just think in general, people like to treat this as one of these statistical things, right? You learn that, oh, it's this and that many SDs and so on. But it doesn't absolve you of the task of thinking about whether it's plausible or not. And sometimes it's implausible, right? Like nobody is like 3 meters tall. So you can discard that person because they are likely like a malicious respondent, right? But if somebody is maybe 2 meters tall, that might as well be the case, right? So you need to actually keep the variable in mind. And I think you should actually also look at the absolute values. I know that people in psychology like to standardize everything. And then they're like, oh, this is 2 SD above the average and so on. But if you look at the original unit, that might also be just very helpful to see whether it's a plausible value or not.
One of the ideas that I think are really underused in both in science and industry, ideas in causal inference, I think are sensitivity analysis and partial identification. I think these are very, very powerful tools that for maybe educational reasons primarily, we don't use that often, we don't discuss them that often, we don't teach them that often. When we met before the recording today, you told me about this new trend in psychology called multiverse analysis, which in my understanding, is a type of sensitivity analysis, which is maybe even additionally powerful in the sense that it might take into account the study setting and so on and so on. Can you tell us a little bit more about this multiverse analysis? What is it, and do you think it's a good idea, and how could it be useful for anyone interested in causal inference?
So this multiverse idea has been, I think, developed multiple times independently in psychology, in sociology, and so on. And it's essentially the idea that you do have all these decisions like outlier exclusion, data pre-processing, but also then how you set up your model, maybe which covariates to include in an experiment and so on. These are all researcher degrees of freedom, right? And you might be able to justify either way, actually. And now the idea of the multiverse is that you just do all of them. So you take all the combinations of all the decisions have in front of you and you just conduct all the analyses. And as you might imagine now, you get into like the territory of factorial explosion, right? Because you combine every possibility with every possibility. And so you do run a large number of analyses. Ideally, there is like one quantity of interest. So you extract that quantity of interest from all of the 1,000 to million models that you're conducting. And then you look at the distribution of these effects. And then you might combine that with looking at how different factors affect the results. And that's a general idea. So multiverse analysis is like, I think, the paper that branded it best, which is why I think this is now the way people call this style of analysis. I think Ioannidis called it vibration of effects. And then there is specification curve analysis from psychologists that actually comes with like a p-value for the whole curve and so on, where it's a bit unclear what the p-value stands for, but it does come with a nice illustration. So people will conduct a specification curve analysis, but then combine it with the label multiverse to get the nicest combination of things. So I have conducted such an analysis myself, and it was specifically to make a point about p-hacking. So substantively, I've done a lot of work on birth order position on personality. So that's the question, are firstborns systematically different from laterborns on various personality traits and so on? And if you look at the literature, and maybe that's to be expected, but it's an absolute mess. And I think part of that is because any finding could be explained after the fact. For example, you could find that firstborns are less social, and it kind of makes sense. But then you could also find that they are more social. Maybe that also makes kind of sense because they're more likely to listen to their parents and so on. And so you have that situation where any pattern could be explained. And one example for this is, so one pattern that we do find in Western countries is that firstborns are slightly slightly smarter on average, but it's only like, maybe a tenth of a standard deviation or a bit more. And it's, of course, not deterministic. I always have to add that because I have a younger sister, right? In any case, I presented these findings, and then one student was like, oh, but they have seen all these TikToks, and they thought it was agreed upon that the later borns are the smartest. And it's like, oh, that's kind of intriguing that you can take it either way and spin it into a story. So anyway, the literature is a huge mess. There are a lot of underpowered studies, and it's very clear that, people just hand out like a large battery of questionnaires. And then somebody is like, oh, wait, we can like reconstruct people's birth order. Oh, so let's compare the groups on all these like 50 variables. And if we find one significant effect, we publish it. And we try to like emulate that process. So we took a data set, we got all the personality variables, we had all these data analytic decisions that could be justified. So for example, which siblings do you count, right? Is it just biological full siblings that you grew up with? Or maybe do half siblings also count if you grew up with them and so on? So you can do that in different ways. And we just did all of that. And as one might have expected, we mostly found nothing because we tend to find no effects of birth order position on personality outside of the intellectual domain, and if we look at adults. So there doesn't seem to be much going on. But we just wanted to make the point that individual specifications light up, like they give you a significant effect. And then it's like, oh, but in larger families, the later born will be score higher on trust if you adjust for gender and if you count all siblings and so on. And we just wanted to make that point and show the whole curve clearly shows you there's nothing going on, but you can pick a point right over there or right over there and tell like opposite stories. And so this is how we used it in that spirit. And I hope it worked well. So I was on the advisory committee of a PhD student who did skeptical work on multiverse analysis. And he was like, no, I invited you because your paper shows like how to use the method well. I think what you can't do with that method is just look at the curve and think that this is like essentially the distribution of the effects and the uncertainty in it, right? So you can't just like say, okay, now I take the average and that is the most reasonable estimate. Because the problem is, of course, that not all specifications are equally justified. Or maybe you think they are all equally justified, but somebody with a bit more expertise in causal inference might tell you, no, it's always better here to control for gender, so you should always pick those specifications, so you actually can just ignore the others. And so I wrote a bit about multiverse analysis and what purpose it serves. So I think if there's a genuine situation where either way is equally defensible and people agree with that in general, then by all means conduct all the analyses, right, and give me all the results, and then hopefully the results agree, because otherwise it will be very hard to find out which defensible analysis should be preferred. But what's more likely to happen, I think, is that there are decisions in there that arbitrary decisions that are not arbitrary at all, such as outlier exclusion, right? This can be more or less correct depending on whether you exclude only the invalid data points or also valid ones. And then there might be decisions in there that are clearly wrong, but the authors just don't know because people don't know how to set up the best possible model, of course, in practice. And so you end up with a bit of like a mosh of various things. And it's just hard what to make of the total specification curve of all the results unless they all agree. If they all agree, you're always fine. You can always say it doesn't matter either way, right? You arrive at the same conclusion, but it often does make a difference. And then you get into the spot where you actually need to think a lot about why this model would be more justified than the other one, always keeping in mind that, of course, there will be sampling variability unless you have infinite data. My take on this now is, so I think it is rarely the right tool to figure out what's precisely the right answer to a research question. I think, again, it has an educational value in that these analyses just highlight also how little we know about how to set up our analyses. So if all these things are all equally defensible, maybe we just haven't thought about how to actually set up the model, how to actually specify an estimate, like which assumptions go into the model and so on. And so this is a bit like the replication project where you just pick 100 studies, no matter whether they actually need to be replicated, and replicate them to highlight something. And I think for the multiverse analysis, it is just like highlighting this one issue. And I think one of the original proponents also has a manuscript that is like, okay, so here's how to use this in a classroom setting. And I think this is very valuable. And I think large parts of the psychological literature are essentially classroom setting, right? We're trying to figure out something together. We are trying to figure out how to improve our practices. So it's less about the specific findings. It's more about highlighting how uncertain we are on these decisions. And I think for that purpose, it's a good thing. Mostly overall, of course, it has been abused. Like everything has been abused. But I do think it highlights important issues. I do think it's really like just educationally, like working through what could be defensible and what isn't and so on is valuable, I think. So I'm not opposed to it, even though I have written a blog post that is quite critical of it. But I do conclude with, maybe it's about the insights we gain along the way and not about these specific analysis results.
We will link to the blog post in the episode description so everybody can learn your critique. You mentioned this educational aspect where we go and we look for different possibilities and we hope to learn something on the way. One of the things that I noticed in your publications is that you also often talk about graphs, like graphical models, DAGs, and so on. What are your thoughts about the usefulness of graphs in your work, and maybe in more general sense when you think about teaching causality to others?
So I love causal graphs. I'm a bit biased here. But I actually do love them for a reason, and that is because I think they are super helpful for teaching and for explaining stuff. And I think a lot of science is just about explaining stuff to others, right? So you have that idea in your head that this is how the data need to be analyzed, but now you need to communicate that. And I think graphs are just a super good way to communicate that. My opinion here might be colored by the fact that I'm a psychologist, and so we do have a strong tradition of structural equation modeling, path modeling, or just people drawing these little process graphs with arrows all over them. So it's a very intuitive language, at least for me as a psychologist. And then I do find that it's super intuitive for my students as well. So I've taught this to like first year undergraduate students in psychology who hadn't heard anything about statistics, but actually don't need much statistics to understand graphs. The one thing is somehow you need to introduce the notion of conditioning on a variable, but you can come up with like easy examples where it just means stratifying, and then it's fairly easy. And then you just say, and you will also learn about regression analysis, which is another way to do that. And then you can let them reason through all of these like complex causal situations. And I think that went really well. So I also used the graphs to explain different types of samples. So in psychology, you usually learn about, there's a probability sample, and then there are convenience samples, and then there are like samples could be selective and so on. And you can all solve that with graphs. And then the trick is just you have like a node that the person gets into your data set. And then in your data, you always have conditioned on that node. And so it's very easy again to see, so there's all these like collider biases introduced between all variables that affect whether a person gets into the sample or not. So it is not trivial, but if you learn the causal graphs from the beginning and use them for everything, it is quite natural for students to understand these situations. And then the rules are super simple, right? It's like algorithmic rules. Like you don't need to think about what the variables mean. You just need to think, two arrows point in here, condition on that, then suddenly non-causal association here. So I really like using them in my own teaching. I even force students in my personality seminar to read like a primer to DAGs. And I think it works quite well because in the seminar, you then critically discuss findings, and the DAGs give you a nice language to also like articulate your criticism. So the authors do this, but actually I think here's this confounder that affects this, and thus this could explain their findings and so on. Now, when it comes to my writing, which maybe is less directly educational, however, I do actually think of all of my papers, including my substantive papers, as having like some educational purpose. Because I think if you read like a paper in psychology, it's always possible that the findings don't hold up and so on. But I want people to get away something that lasts. I think what you can get away, what lasts, are like more general insights about how causal inference works, or maybe how statistics connect to causal inference and so on. And so my ideal is that people might read this without actually being interested in personality much, but then be like, of course, this is how it works, right? And just take that insight, maybe forget about where they got it from, and then just move on. And maybe later apply it somewhere in their own work for a completely different topic, just being aware of like the individual structures that could induce bias and so on. And so this is why I use them in my own writing as well. So I know that people also like to hate on DAGs because they cannot represent everything and because it's not helpful for everything. And I fully agree with that. I don't think they need to be helpful for everything to be helpful for some things. And I think a difference here might also be, I think psychologists are very focused on like communication and making things accessible. And then you have more technical literatures where it might even be a point of pride that it's hard to follow along. And I'm not sure, maybe I'm being uncharitable here. Maybe it's just those people don't know better how to make it accessible because it's also hard. But at least, for example, like among economists, I do have the feeling that for them it's like, oh no, it's only like you need to understand methods the hard way so that it's actually like a costly signal that you got the difference in difference, right? And so on. So it's just like making it harder so you can distinguish between levels of skills and so on. And I think from that perspective, it's like, oh, what do the DAGs add, right? You don't need the DAGs. You can do it without the DAGs. You just need to think harder, right? But for me, it's like I don't operate on the assumption that people enjoy thinking hard. I know there are people who do that, and it's good for them. And there are whole fields of these people, but in psychology, people don't necessarily enjoy working through proofs and so on. Right, so I really prefer to have something that is accessible, and then it's not automatically accessible, right? So you need to work through, okay, so a reader who doesn't know about these things, what will they think about this? How will they be able to follow along? And so I'm thinking about DAGs as tools for that. So there isn't also like the one true DAG that you draw, but there's like a DAG that you draw to illustrate a point, a specific point. And I'm much more likely to use them in that spirit than in the spirit of here's the DAG that justifies my analysis according to Daggerty. Although that's also a good use case. I think I would love it if people did that. But for me, it's more like highlighting specific complex causal structures that are not trivial unless you already understood them. And if they are not trivial to you, the graph might be an easier way for you to grasp it. And then if the graph doesn't work, so I have situations where I feel like this substantive example actually works better than the graph. But you can always just present both. So I do think like people like to be like, oh, I need to write this like short and there should be no redundant information. I think most papers are published online these days anyway, so space isn't actually the big concern. And I would much rather people have write longer papers that are more accessible. Because if you have the paper shorter, well, it's faster to read it, but it's not necessarily faster to actually understand it. So I prefer to just offer redundant information and multiple angles and so on. And the DAGs are one very, very valuable part of that.
I really think you are making a valuable point when it comes to the criticism of the idea that, well, DAGs are not useful for everything. Of course they are not. And I met these arguments online as well, sometimes very surprised by them, because it seems like some of the people, at least, who are using this kind of criticism or presenting this kind of criticism assume implicitly that DAG should be a full causal model, a fully specified causal model, while we know exactly, if we look at the history, how these graphical models, how Pearl proposed them, why he proposed them, for what reason, and what stage of his discovery of the framework or construction of the causal framework that we currently know as the structural equation model framework. We know that DAGs are just a tool, just a structural information. It's just structural information induced by the structural causal model. By definition, they are not complete. They cannot describe everything in a causal model, and they are not designed to do so. So I think that's a very valuable thought for anyone who's maybe thinking about the role of DAGs. They could be useful for in their specific use cases and setting expectations. Before we finish, I wanted to ask you a question from another dimension. What were two books that changed your life?
Oh, that is a really tough one. This is really hard because this is a causal question, right? Whether it changed my life. So there would need to be a counterfactual world in which I did not read the book and things turned out differently. So I'm going to do the psychologist thing here and like just pretend to answer a different question. So I think as far as social sciences are concerned, there is actually one like social science pop science book that I really enjoyed. and that I think did affect my finding and my thinking, and that is Everything is Obvious Once You Know the Answer by Duncan Watts. And I read that a couple of years ago, but I had the impression it aged well despite the replication crisis and so on, and had some valuable like pointers towards traps, how you might like fool yourself into thinking that you know something when you don't, and so on. So I really enjoyed that one. And then another one that I actually really enjoying right now, and that I do think is shaping my thinking, is by Adam Kucharski. I don't know how it's pronounced in English, Kucharski or something. An epidemiologist who has written a book called Proof, Uncertain Signs of Certainty. And so this does cover a lot of causal inference, but across like very different contexts, including the history of various statistical approaches and so on. In a manner, it's like a very, very general book, like how can we be certain about anything, right? And then it does talk about, for example, mathematical proofs, about proofs in a legal context, about law, but then also like how do we know about causal effects, like what's the proof that an association is actually like there and not just variability and so on. And I'm really enjoying this. So this is, I think, the first supposedly pop science book that I really feel has been written for somebody like me. I'm also cited in like somewhere in there, which is why I started reading it in the first place. But I really enjoy that, and I think I do want to kind of move into that direction with my teaching, that it is a lot more generous science. So it's not just, how do we run studies in psychology and what does that tell us about the world, but it's more about, okay, what are in general the principles? How can we generate causal knowledge? And then the examples can be from psychology. I mean, some will have to be from psychology so that students are not like, what the hell is going on here? But I do actually think there are a lot of other contexts that are of interest also to students. So, for example, health issues, I think, are always of interest. Then I just really got into lab muffin beauty, like Michelle Wong, who is a beauty or skincare YouTuber, but is going really deep into, okay, how can we know which products work and which don't, what are the procedures in the lab and so on. And so she has a very, very nice book where there's a very fun section on you try out different skincare products, but how do you know whether they actually work? Right. And so she suggests that you can do a trial on yourself and you use half of your face as control. So you have a new product, you apply to one half of your face, right? And then you don't apply it to the other half and so on. And I'm just like, yeah, no, that makes perfect sense. And actually, I think that would have been useful information also to have much earlier on, right? Like as a teenager, that it would have been, that makes perfect sense. And this is how it should be done, right? And it highlights okay, you need a control group, right? And then it's, and immediately like potential confounders come to mind. So, for example, you might be sleeping on one side of your face, right, which changes things. And then, okay, that's an issue here. So maybe it's not perfect, but maybe it's as good as it can get for your individual face and so on. And so I do really like just that angle to bring in more fields of research and so on. And I actually think it's, even if you have students who wanted to study psychology, I think, some of them discover that psychology is not for them. Some of them move on to study medicine or to go into a different field. And I would like to give them something. And also if they move into the industry, to give them something that just applies generally. So here's how you find out whether something works in your own life, if you're later working for a company and so on. And here's how to use these things and how to design these studies so that you can actually learn something, maybe just about yourself, maybe about the wider world. And I think that's a really cool way to put it. And Adam's book fits right in there. But I think there's a lot of material actually that you can use from different fields of research to make these points.
What would be your advice for someone who is starting or entering a complex field like science in general, machine learning, causal inference?
General advice is always hard. Because I think it always depends on the specific of what you're doing. If this is about you are starting maybe as a PhD student, and this is the psychologist speaking, but I would take great care to find a good advisor. And you do find that out by secretly talking to former grad students or other grad students and finding out what the advisor's like. Because in my experience, that makes such a big difference. So for well-being on the one hand, and I do think that's important, I did my PhD on well-being, So I do think that matters, but also I think just for your like intellectual development. So there are these labs where students are just taught you should do what everybody else is doing to crank out those papers. And I think that is not a great way to learn things. And so if you can identify upfront that this advisor would make you do that thing, you can just say, no, it's probably not worth it. And so my angle there is always like if you decide to go into a field, it is a commitment, right? Like it will have all sorts of downstream consequences. And so I would make sure in the beginning that this is a place where you feel good, where you feel comfortable, and where you feel like you can actually learn things. And then the rest like follows later. But I would just like ensure that you don't get yourself into an abusive environment where you're then stuck for some time and at some point you feel like you can't leave the field anymore. So I've had multiple points in my career where I considered leaving psychology, like after my bachelor's degree, after my master's degree, and maybe also sometimes now, right? And I do think it's healthy just to consider like what I'm doing, is it like a useful way to spend my life, because we spend a lot of time at work. Do I really want to do that? And I mean, you might actually be able to say more about that, right? Because you've switched a lot more. But I do think it's healthy to think about that, like whether this is what you want to do. I think it's good to take into account the quality of research of the field. So I have some students who are like, oh, wow, you're telling us all these stories about psychology, and that's quite awful. And so what I usually answer to them is like, yes, actually, I think if I could start out again, maybe I would study something else. On the other hand, there are worse places than psychology. Psychology is having good discussions. And if you stay, you can make a difference. Right? And then you need to take these things into account and figure out what you want to do. Because I also don't want all students who care about science to drop out of psychology just because of reproducibility issues, right? That would be like a very unfortunate selection effect leading to like an even worse field. So I think you should keep in mind all of these aspects, and then there will be so much uncertainty, right? So it will be very hard to tell up front. So I would, I think, prioritize like immediate well-being and being in a good environment. And I think if you're in a good environment, it's also always easy to like, change tracks and so on. So if you have like a good advisor, if the field doesn't work out for you, they might tell you, or they might say, oh, we need to refocus on something else to make this work for you and so on. Have a good advisor so that you have the behavioral flexibility to adjust to new information coming in.
What's your message to the causal community?
So I just attended Eurosim, where I got invited. I wouldn't have attended it otherwise. And as expected, it was very hard for me to follow along any of the talks, actually. Oh, that's kind of concerning. But then I met other people I knew, and they were like, no, I also don't understand anything, and so on. I think for the more technical causal inference community, I think my message would be is that it is important to try to build bridges and reach out to more applied researchers in a good manner. So this might involve maybe simplifying things and so on and providing less technical explanations. I don't think so. The image I used in my talk at Eurosim was like a ladder. And it's like a different causal ladder. At the very top, you have the people developing new causal inference methods, developing new algorithms and so on, generalized solutions. I was informed about the existence of targeted learning in great detail there and so on. It's all happening up there. And then at the very bottom, you have the applied researcher who's trying to scramble to write a paper, right? Having barely understood that correlation does not equal causation. And so at the very top, there's good stuff happening that could help improve the research happening down there, but the knowledge needs to get passed down, right? And so I think there are multiple steps usually involved. So the people who are developing new methods don't need to write tutorials for applied researchers. They would not be efficient usage of anybody's time. But I think it's breaking it down for slightly less technical people. And then at some point, maybe I'm on that ladder, right? So I'm very close to the applied researchers. So I really try to get people who are doing their own substantive research with little technical guidance and so on. And so I would just like to see more people from the top reaching out down. I already see a lot of that happening. So we do have great causality communicators and so on. I also acknowledge that this is hard. This is a theory of mind task, right? Dumping things down for people who are slightly less advanced in their technical understanding than you. But I would like to see more of that. I think causal inference researchers should do that more for the very selfish reason that it is just nice to have an impact on actual practices. So in psychology, we have a similar situation. We have like our own psychological methods field, which is really a distinct field with its own journals, and not every field of research has that. But you can already tell that there is not that much actually flowing into the applied research community. And so there are stories about the German Methods Conference, and somebody will be like, I developed that model, so does anybody know anybody who could have data on which we could actually fit it? Right? So it's developing a model for its own sake without any actual use case available anytime soon and so on. And I think everybody could profit from a bit more exchange here. And of course, this is also like a two-way thing, right? It's not just like the technical people provide resources and reach out, but also, of course, the applied researchers need to step up their game. So I think for that also we need to kind of like make sure during peer review and so on that the right issues are flagged so that the applied researchers are pushed to actually look at what's going on there on the more technical side. But yeah, that's also something I'm working on. So I think we can make great progress there. And I actually think there are a lot of like really low-hanging fruits, like just confusions in the applied literature that could be easily resolved by somebody with a bit more expertise in causal inference. So I think there are low-hanging fruits to be picked there by venturing out into the more like gritty applied world. And I know it can be depressing because then you actually see how bad the studies are on average and so on. But I think it's a worthwhile endeavor because I think ultimately everybody in science, I think, does care about like the collective output of science, right? Like, is the field of psychology working well? Like, is the research and the findings we are churning out, is that actually reliable and so on? And I think everybody has an interest in that, even the people who only develop the models and so on.
Great. Thank you so much, Julia. I really appreciate your time. It was a great conversation. And I would love to ask you, I have at least 5 more questions here, but I think we need to take it maybe for part 2 of our conversation. I really appreciate it. It was a great conversation. Any closing remarks from you?
I had so much fun talking to you. So.
Sorry. Any closing? I asked if you have any closing remarks before we say goodbye.
No, I don't really have any closing remarks.
Thank you so much. Thank you for finding time to speak to us, and I'm confident that the community will really love this conversation.
Yeah, thank you for having me.
Thank you.